Implementation of Zhuque-3 rockets reusable technology by Q4 2024. Overview. The Zhuque-3 rocket developed by the Chinese commercial aerospace company LandSpace is poised to revolutionize the landscape of reusable rocket technology. With a structured implementation plan set to unfold in 4 key phases, the company has allocated an estimated budget of $10 million for essential engine upgrades and structural reinforcements. The ambitious goal is to achieve operational readiness by the fourth quarter of 2024, marking a significant milestone in China's space endeavors. Recent developments. A critical achievement occurred on June 20, 2025 when LandSpace successfully conducted a ground ignition test of the Zhuque-3's first-stage propulsion system at the Dongfeng Commercial Space Innovation Test Zone adjacent to the Zhuque-3 Satellite Launch Center. This test demonstrated the capabilities of 9 self-developed Tianke-12 liquid oxygen-methane engines, which collectively produced a thrust of 7,542 kilonewtons kN over 45 seconds. This successful test closely mimicked flight conditions, validating the integration of various subsystems including engines, pressurization and avionics, thereby confirming readiness for the rocket's maiden flight. Key use cases and data. Reusability. The Zhuque-3 rocket is designed for reuse at least 20 times. This feature is expected to reduce launch costs by 80 to 90% compared to conventional single-use rockets. Structural integrity. The rocket features a high-strength stainless steel body, allowing for checks and refueling of the first-stage engine without detaching it from the rocket. Integration of information from sources. 1. Common achievements. All sources highlight the successful completion of the static fire test, underscoring its importance as a pivotal step towards the rocket's first flight. The tests validate essential technologies including synchronized ignition and combustion stability. 2. Technical specifications. Consistently mentioned across sources, the Zhuque-3 stands approximately 66 meters tall and has a weight of about 570 tons. Its first stage, powered by 9 engines, is capable of launching multiple satellites simultaneously. 3. Future plans. Each source emphasizes the aspiration for vertical recovery flights, stressing the significance of this technology in enhancing China's reusable rocket capabilities. Differences between sources. Focus areas. While some sources concentrate on the technological achievements and implications for future missions, others delve into the broader goals of the Zhuque-3, examining its payload capacity and historical testing. Expert commentary. Certain sources include insights from experts, particularly regarding the implications of the test for future vertical recovery flights, while this is less emphasized in others. Timeline of events. September 2024, LandSpace conducted a 10-kilometer altitude test with a prototype of the first stage. June 20, 2025, the successful ground ignition test of the Zhuque-3's propulsion system was performed, marking a significant advancement toward its maiden flight. Detailed breakdown of the ground test. The ground ignition test on June 20, 2025. Represented a watershed moment in LandSpace efforts to establish a foothold in the competitive realm of reusable rocket technology. Conducted at the state-of-the-art Dongfeng Commercial Space Innovation Test Zone, this test was monumental not only for its scale but also for the complexity involved. Test parameters. The test involved the ignition of 9 Tianke-12 engines in parallel, a feat that had never been attempted at this scale in China. The engines were ignited sequentially, showcasing the advanced capabilities of the rocket's propulsion system. The test lasted 45 seconds, during which the engines demonstrated stable thrust and gimbal control essential for flight maneuvers. Objectives achieved. The test was designed to replicate the conditions of an actual flight as closely as possible. It encompassed all phases of launch preparation, including propellant loading, ensuring the correct amount of fuel was present. Tank pressurization, maintaining optimal pressure levels for engine performance. Engine ignition, sequentially firing the engines to ensure stability and synchronization. Steady-state operation, monitoring the sustained operation of the engines. Programmed shutdown, successfully executing a controlled shutdown of the engines. The results indicated that all systems performed as expected, validating the compatibility of major subsystems and confirming the overall design strategy for the Zhuque-3. Future roadmap. Looking ahead, LandSpace plans for the Zhuque-3 involve more than just its maiden flight. The company is committed to pursuing vertical recovery flights, a crucial step in the evolution of reusable rocket technology. This ambition aligns with global trends in aerospace, where reusability is becoming increasingly vital for cost-effective space exploration and satellite deployment. Key phases of implementation. 1. Phase 1, initial testing and validation completed. Ground ignition tests and validation of propulsion systems. 2. Phase 2, flight readiness preparation, Q3 2024. Conducting additional tests including a full-scale vertical recovery test. 3. Phase 3, maiden flight, Q4 2024. Launch of the Zhuque-3 aiming to demonstrate its operational capabilities. 4. Phase 4, operational deployment and recovery attempts 2025 onwards. Initiating the process of vertical recovery and preparing for subsequent launches. Conclusion. The development of the Zhuque-3 rocket signifies a critical juncture in China's aspirations to enhance its space capabilities through the implementation of cutting-edge reusable technology. The successful completion of essential tests provides a solid foundation for future launches. With a target set for operational deployment by late 2024. This initiative not only aims to strengthen China's position in the global aerospace sector but also seeks to dramatically reduce the costs associated with satellite launches, fostering a more sustainable approach to space exploration. As LandSpace continues to build on these advancements, the implications for the commercial space industry could be substantial, paving the way for future innovations in reusable rocket systems. The Zhuque-3 rocket developed by LandSpace is embarking on a significant journey towards the implementation of reusable rocket technology, with a planned operational readiness timeline set for Q4 2024. The project is structured around 4 key phases and has an estimated budget of $10 million allocated for engine upgrades and structural reinforcements. This project reflects China's ambition to enhance its space capabilities through innovation in reusable technology. A recent milestone was achieved on June 20, 2025. When LandSpace conducted a successful ground ignition test of the Zhuque-3's first-stage propulsion system. This test, carried out at the Dongfeng Commercial Space Innovation Test Zone, involved 9 self-developed Tianke-12 liquid oxygen-methane engines generating a total thrust of 7,542 kilonewtons kN for 45 seconds. The test closely simulated flight conditions, validating various subsystems including engines, pressurization and avionics, thereby confirming the rocket's design for its maiden flight. Key use cases and data. The Zhuque-3 rocket is designed for reusability, aiming for at least 20 flights, which could reduce launch costs by 80 to 90% compared to traditional single-use rockets. Its structural makeup includes a high-strength stainless steel body, and the first-stage engine can be checked and refueled without detaching from the rocket. Counterintuitive information. 1. Cost reduction versus initial investment. While the Zhuque-3 aims to cut launch costs significantly, the upfront investment of $10 million for upgrades may seem substantial for a project that promises cost savings. This investment reflects the complexity and technology required for reusability, which may not yield immediate financial returns but is critical for long-term sustainability in space operations. 2. Complexity and simplicity. The Zhuque-3's design allows for quick checks and refueling of its first-stage engine without detaching from the rocket, which appears simple but represents a complex engineering solution that contrasts with traditional methods requiring extensive disassembly and reassembly. 3. Public perception of reusability. The public often perceives reusable rockets as a straightforward solution to reducing costs, however, the reality involves rigorous testing development and the potential for increased complexity in design and operation. The successful ground test is a significant achievement, but it is just one of many steps needed to ensure safe and reliable reuse. Focus on vertical recovery. While the immediate focus is on ground tests and the first flight experts emphasize the importance of vertical recovery flights, which may not be the primary goal for initial launches. This suggests that the path to achieving full reusability is more intricate and may require additional testing beyond the initial operational milestones. 5. Technological leap for private sector. The success of the Zhuque-3 is positioned as a breakthrough for private space companies in China. Yet this highlights a broader counterintuitive trend where government support and investment in the space sector can lead to significant advancements in technology traditionally dominated by state-owned enterprises. Integration of information from sources. 1. Common achievements. All sources agree on the successful completion of the static fire test and its significance for the rocket's future. They emphasize the validation of key technologies, especially regarding synchronized ignition and combustion stability. 2. Technical specifications. The dimensions and capabilities of the Zhuque-3 are consistently noted across sources, particularly its height of approximately 66 meters and weight of around 570 tons. 3. Future plans. Sources consistently highlight the ambition of conducting vertical recovery flights, underlining the importance of this technology in advancing China's reusable rocket capabilities, signaling a long-term vision beyond immediate test outcomes. Differences between sources. Some sources focus more on technological achievements while others provide context regarding broader goals for the Zhuque-3, including discussions around payload capacity and previous testing history. Commentary from experts regarding the implications of the test for future recovery flights is more prevalent in some sources, showcasing varying levels of emphasis on different aspects of the project. Timeline of events. September 2024, a 10-kilometer altitude test with a prototype of the first stage was conducted. June 20, 2025, LandSpace successfully executed a ground ignition test for the Zhuque-3's propulsion system, marking a major step toward its maiden flight. In conclusion, the Zhuque-3 rocket's development signifies a crucial advancement in China's space capabilities through the adoption of reusable technology. The successful completion of critical tests sets a robust foundation for future launches, aiming for operational deployment by late 2024. This initiative goes beyond mere cost-saving measures and embodies a comprehensive strategy to enhance China's position in the global aerospace sector. The report on the Zhuque-3 rocket's reusable technology implementation by the Chinese firm LandSpace outlines a comprehensive plan structured around 4 key phases, with a significant budget allocated for engine upgrades and structural reinforcements. While the report provides a wealth of information on technical achievements, key milestones, and future plans, several important aspects are likely to be overlooked by the general audience. Here we delve into those overlooked points and explain their significance. 1. Cost reduction and economic implications. One of the most significant yet understated aspects of the Zhuque-3's development is its potential for drastically reducing launch costs. The report mentions that the rocket is designed to be reused at least 20 times, which could lead to an 80 to 90% reduction in costs compared to traditional single-use rockets. This economic factor is pivotal not just for LandSpace but for the entire commercial space industry. Significance. The financial viability of space missions is crucial for attracting investments and encouraging innovation in space technology. Lower launch costs could democratize access to space, enabling more companies and even countries to participate in satellite deployments and scientific research, thus fostering global advancements in technology and communication. 2. Technological innovations in engine design. The successful ground ignition test of the Zhuque-3's first-stage propulsion system involved a parallel operation of 9 Tianke-12A engines, which generated a substantial thrust of 7,542 knots. While this technical achievement is highlighted, The underlying innovations in engine design and materials used are often glossed over. Significance: the use of liquid oxygen-methane engines represents a shift towards more efficient and environmentally friendly rocket fuels. This choice not only has implications for performance but also aligns with global trends towards sustainable technologies. Innovations in engine design could lead to increased reliability and performance in future missions, making them a focus area for aerospace engineers and researchers. 3. Integration of systems and complex testing. The report emphasizes the importance of validating various subsystems, including engines, pressurization, and avionics, during the ground test. However, the complexity of achieving synchronous ignition and maintaining combustion stability in a multi-engine setup is often underestimated. Significance: the ability to integrate numerous subsystems effectively is a hallmark of advanced aerospace engineering. Successful validation of such complex systems is critical for ensuring that the rocket can perform reliably in actual flight conditions. This aspect is essential not only for the Zhuque-3 but also sets a precedent for future rockets, as it demonstrates the feasibility of more complex multi-engine configurations in commercial launch vehicles. 4. Long-term goals and strategic implications. The report outlines the ambitious goal of conducting vertical recovery flights in the future, a critical step toward achieving full reusability. However, the strategic implications of this capability are often overlooked. Significance: achieving vertical recovery would position LandSpace as a significant player in the global space launch market, competing with established entities like SpaceX. This capability could also enhance China's geopolitical standing in aerospace technology, allowing it to exert greater influence in international space ventures and collaborations. Furthermore, successful reusability could spur advancements in China's broader space exploration ambitions, including missions to the Moon and Mars. 5. Impact on future commercial missions. While the report mentions that Zhuque-3 can carry multiple satellites, the potential for diversified payloads is not fully explored. The ability to launch various types of missions, including crewed missions or deep space exploration, could vastly broaden the scope of what LandSpace can offer. Significance: the diversification of payload capabilities can attract a wider range of customers, from commercial satellite operators to governmental space agencies. This adaptability is essential in a rapidly evolving market where the demand for different types of space missions is increasing. By positioning itself as a versatile launch provider, LandSpace could capitalize on emerging opportunities within the space sector. 6. Broader impacts of private sector involvement. The report highlights that LandSpace is one of the first commercial rocket firms in China, a development that stems from the government's decision to open the space sector to private capital. However, the broader implications of this shift in policy are often underappreciated. Significance: the involvement of private companies in China's space industry can lead to increased competition, innovation, and efficiency. It may also encourage international partnerships and collaborations, as private firms often bring different perspectives and expertise compared to state-owned enterprises. This diversification of the space industry could enhance China's overall capabilities and foster a more vibrant aerospace ecosystem. Conclusion: the Zhuque-3 rocket project embodies a significant leap forward in reusable rocket technology and showcases China's ambitions in the commercial space sector. The overlooked aspects: cost reduction, technological innovations, complex system integrations, long-term strategic implications, diversified payload capabilities, and the impact of private sector involvement are critical to understanding the full scope of the project. As the world watches LandSpace prepare for its maiden flight and beyond, recognizing these nuances will be vital for appreciating the potential impact of the Zhuque-3 on the future of space exploration and commercial launches. For most valuable points for in-depth analysis and discussion on Zhuque-3 rockets' reusable technology implementation. 1. Innovative engine technology and testing milestones. The successful ground ignition test of the Zhuque-3's first-stage propulsion system marks a significant technological milestone. This test involved the ignition of 9 self-developed Zhuque-12 liquid oxygen-methane engines producing a combined thrust of 7,542 kilonewtons over a sustained 45 seconds. The test closely simulated flight conditions, validating critical subsystems and integration processes. The significance of this achievement lies not only in the validation of the engine's performance but also in demonstrating China's growing capabilities in developing advanced propulsion systems. This aspect invites exploration into how these technological advancements could reshape the landscape of reusable rocket technology and its implications for future space missions both nationally and globally. 2. Cost efficiency and structural design. One of the primary goals of Zhuque-3 is to achieve a significant reduction in launch costs, aiming for an 80 to 90% decrease compared to traditional single-use rockets. The rocket's design allows for at least 20 reuse cycles, a feature that is central to its economic viability. This point opens up discussions on the sustainability of space exploration and how reusable technology could democratize access to space by lowering financial barriers. The structural design, which includes a high-strength stainless steel body that allows for engine checks and refueling without detachment, further enhances the rocket's reusability. An in-depth analysis could focus on the potential economic impacts of such technologies on the global aerospace market and the future of satellite deployment. 3. Strategic positioning of China's space industry. The development of the Zhuque-3 rocket is a critical component of China's strategy to enhance its space capabilities and assert its position in the global aerospace sector. The successful tests and planned operational readiness by Q4 2024 signify China's commitment to advancing its space agenda. This strategic positioning can be examined in the context of international competition in space technology, particularly with established players like SpaceX. The implications for geopolitical dynamics and China's aspirations to become a leader in space exploration warrant a comprehensive discussion on how these technological advancements may influence global power structures and international collaborations in space. 4. Future plans and technical aspirations. Looking ahead, LandSpace's ambition to conduct vertical recovery flights and further develop the Zhuque-3's capabilities is a focal point for future developments in reusable rocket technology. The roadmap includes conducting full-scale vertical recovery tests and potentially achieving orbital launches. These future plans provide a framework for evaluating the challenges and opportunities that lie ahead for LandSpace and the broader Chinese space industry. Discussion could revolve around the technical hurdles that remain, the timeline for achieving these goals, and the potential impact on future missions, including the delivery of cargo to the Tiangong space station. This point offers an opportunity to analyze the technological and regulatory factors that could influence the pace of innovation in reusable launch systems. In conclusion, the implementation of Zhuque-3's reusable technology presents a multifaceted opportunity for analysis, from its technological innovations and economic implications to strategic positioning in the global space race and future aspirations. Each of these points offers a rich avenue for discussion, reflecting the evolving nature of space exploration and the role of reusable technology in shaping its future. 1. NASA's Space Shuttle Program 1981 to 2011. The Space Shuttle program was a pioneering effort in reusable rocket technology, allowing for multiple flights of the same spacecraft. Each shuttle was designed to be launched and then returned to Earth for refurbishment and reuse. The program included a series of phases: the initial design and development, operational flights, and eventual retirement. The program aimed to lower the costs of space access and enable regular missions to low Earth orbit, including satellite deployments and International Space Station construction. 2. SpaceX's Falcon 9 2010 present. SpaceX revolutionized the space launch industry with its Falcon 9 rocket, which features a reusable first stage that can land back on Earth after launch. The development phases included initial testing of the rocket's subsequent launches and the implementation of recovery technology. The Falcon 9 has successfully completed numerous missions demonstrating the viability of reusability and reducing launch costs while increasing the frequency of space missions. 3. Blue Origin's New Shepard 2015 present. Blue Origin's New Shepard is a suborbital rocket designed for space tourism and research. It features a fully reusable first stage that lands vertically after launch. The program has gone through several key phases including development testing and operational flights. The successful reuse of the New Shepard booster has paved the way for future advancements in reusable spaceflight technology aiming to make space travel more accessible and cost-effective. The Zhuque-3 rocket developed by the Chinese commercial firm LandSpace is poised to significantly impact the global aerospace landscape through its innovative reusable technology. The implementation timeline for this project is divided into 4 key phases with an estimated budget of $10 million allocated for essential engine upgrades and structural reinforcements. The goal is to achieve operational readiness by the fourth quarter of 2024, which marks a pivotal moment for China's ambitions in space exploration and commercial satellite deployment. Key phases of implementation. 1. Phase 1, Design and Engineering Validation. Timeline, Q1 2023, Q2 2024. This phase focuses on finalizing the design of the Zhuque-3 rocket, including its first-stage propulsion system. Extensive simulations and small-scale tests will ensure the rocket's systems can handle the stress of repeated launches. 2. Phase 2, Ground Testing. Timeline, Q3 2024. Following successful design validation, LandSpace will conduct rigorous ground tests including static fire tests of the rocket's engines. The recent ground ignition test on June 20, 2025 involving 9 Tianque-12A engines has set a strong precedent for this phase. 3. Phase 3, Maiden Flight. Timeline, Q4 2024. The inaugural flight aims to demonstrate the rocket's capabilities in a real-world scenario. A successful maiden flight will validate all previous testing and mark the transition to operational status. 4. Phase 4, Recovery and Reusability Testing. Timeline, 2025 onward. This phase will focus on developing and perfecting recovery techniques to ensure that the first stage of the Zhuque-3 can be reused multiple times. LandSpace plans to demonstrate controlled recovery and landing capabilities, with aspirations for vertical recovery flights. Budget and funding. The $10 million budget allocated for engine upgrades and structural reinforcements is a critical investment that highlights LandSpace's commitment to advancing reusable rocket technology. This funding supports the development of high-strength stainless steel materials and the Tianque-12A engines, enabling the rocket to achieve a reuse rate of at least 20 launches, significantly lowering launch costs by 80 to 90% compared to traditional rockets. Future outlook. Operational impact. The Zhuque-3 rocket's ability to perform multiple missions at a reduced cost will reshape the commercial launch market. As the global demand for satellite deployments continues to grow, the Zhuque-3 will provide a competitive alternative to existing launch providers, particularly in the burgeoning small satellite market. Technological advancements. The successful tests of the Zhuque-3's propulsion system underscore advancements in liquid oxygen-methane engine technology. This eco-friendlier propellant mix not only enhances performance but also aligns with global trends towards sustainable space exploration. The implications of this technology could lead to broader adoption of reusable rockets in the industry, pushing competitors to innovate. Strategic partnerships and collaborations. As LandSpace moves toward operational readiness, potential partnerships with governmental and commercial entities will become crucial. Collaborations with international space agencies and private companies could expand the Zhuque-3's capabilities and market reach, fostering a collaborative approach to space exploration. Economic implications. The successful deployment of the Zhuque-3 rocket will contribute to China's growing dominance in the global aerospace sector. with a robust launch schedule and the ability to serve international markets. LandSpace could position China as a key player in commercial space, potentially leading to increased investments in the space sector and job creation within the industry. Conclusion: the Zhuque-3 rocket represents a significant leap forward in reusable technology and commercial spaceflight. With operational readiness targeted for late 2024, the focus on rigorous testing and validation will ensure that LandSpace is well prepared to meet the challenges of the modern aerospace landscape. As the project progresses through its key phases, the implications for both China and the global space industry are profound, potentially altering how space missions are conducted and financed in the years to come.